Welcome back, guys. So after creating our enemy prefab, let's now implement the enemy class. So double click on it and let's jump right into it. Okay, first things first. We are gonna make a state machine for our enemy because the enemy will have two main states. Maybe three, but we are gonna use only two for now to keep things simple. The first state for the enemy will be the idle state. It's the state he's just standing and waiting for a runner. The second state will be the running state, in which the enemy is running towards its target. So let's do that. First, we want to create a new enum called state, and this will have two options, the idle state and the running state. Okay, perfect. Then we want to create a new header for our settings. The settings category will have some variables, like for instance, a field for our search radius. So this will help us determine how far the enemy will be able to search for any runner. Then when he's found a runner, we can add a new variable for the move speed. All right, perfect. After that, let's create a variable for our state. So let's just call it state. And finally, we want a new variable for our target, or maybe let's call it target runner. Perfect. So in the update method, what do we want to do? Let's call a new method in here and call it manage state. Perfect. Let's create it. Private void manage state. As we did before, we are going to use a switch statement right here. So depending on the state of the enemy, what do we want to do? In case the state is equals to idle, we ideally want to search for a target. Then we can break. All right, perfect. And the next case will be the case in which the state is the running state. So the case when the enemy is running towards the runner, we can just say run towards target. Perfect, and break. All right, let's now create these two methods. So private void search for target. Okay, perfect. And the second one will be a private void method to run towards target. Okay, perfect. Let's just create a method to switch from the idle state to the running state. So let's call it start running towards target. Okay, perfect. We now have our three main methods. Let's now implement the search for target method. So we are going to search for any runner nearby. So let's create a new array of colliders. Let's call it detected colliders equals physics. We are again going to use the physics class dot overlap sphere to use the overlap sphere method. So this will create a sphere basically around any position again. And we want to specify a radius next. So let's create a sphere around the enemy. So from the enemy position, and the radius will be our search radius. Perfect. Now we are going to loop through all the detected colliders. So from 0 to detected colliders.length. And we are going to try and find a runner. So for that, we can add a condition. If the current detected collider has, so we're going to try and get some component, has a runner component. Okay, has a runner component. We haven't created this runner component yet, but we are going to do so right in the next session. Anyway, if the detected collider has a runner component, what do we want to do? First off, we want to check if the runner we've found is a valid target. If it has already been targeted by another enemy, we can just pass and search for another runner. So if the runner is target, if it's already a target of another enemy, we can just continue. So go to the next index. Otherwise, it's not a target. So let's set this runner as a target. So let's call a method that we are going to create later. Runner.setTarget. Okay. We also want to specify that our target runner, so the private field, the private transform that we've created here, is equals to this runner. So just in order to store it, to be able to follow it or run towards it later on. After doing that, we can start running towards our target. Perfect. In this method, we are just going to say something quick, which is state equals state.running. It's just to change the state of the enemy. This will allow us to switch from this case to this case. Okay? So now the run towards target method will be called inside the manage state method. Okay, so let's implement this one. So first thing here, we want to check if the target runner equals null or not. If it's equals to null, we can just return. It's just a precaution here because we have normally found a runner in the search for target method. But anyway, next we want to modify the position of the enemy. So it's going to be transform.position equals, and there's a cool method in the vector3 class to move our enemy as we wish. It's called move towards, and it returns a vector3. So we are going to move towards our current position, which is the position of the enemy, transform that position. The target is the position of the target runner, so target runner.position. And the max distance delta will be dependent on the FPS of the device, so it's going to be time.delta time times our move speed. Perfect. Then, while moving towards the runner, we want to check if we are close to it or not. If we are too close to it, we want to destroy both the runner and the enemy. So, if the distance, and again we are using a method inside the vector3 class, which is called distance. It takes two vector3s as arguments. So the first one will be the position of the enemy. And the next argument will be the position of the target runner. Okay, so now that we have the distance between these two transforms, let's check if it's less than 0.1 f, let's say. That's a certain threshold. So when the distance will be less than 0.1, this code will be executed. Okay, so what do we want to do in this code? We can just say destroy the runner, so target runner.game object, and we also want to destroy this game object. So now we are destroying the runner and the enemy. And I think we're pretty much done, but the only thing we forgot here is when we start running, we need to remember that the animator of the enemy is by default playing the idle animation. So we just want to grab the component, the animator component, so animator, and we want to play the run animation. And this completes the script for our enemy. Perfect. Okay, cool. So now it seems that we've got an error in the enemy script, and this is normal because we haven't created our runner class yet. But this is exactly what we are going to do in the next session. So see you there.